the idea behind this session is to talk about some of the ideas behind how you can use the charts that we have in JavaFX and then actually extend those. Because the way that they've been designed means that you do have the ability to take the chart classes that the actual charts are built on, the abstract classes, and extend those so that you can develop your own particular charts that meet your own requirements. Now, we do give you a fairly rich set of charts as it is, but there are always situations that you'll find where you need some different way of representing data. So it's nice to have the ability to actually be able to customize the charts that we have and also extend them in ways that you need to do. So we'll talk about a number of different examples of that as we go through. Now, as usual, we have to have the obligatory legal slide which says that, this is just a guess at what our general product direction is going to be. Please don't base any purchasing decisions on what I'm going to tell you. I'm not sure you can actually purchase what I'm going to tell you, but right. So in terms of the agenda, we're going to talk about the basics of the charts in JavaFX. This is one of the things that's really nice about JavaFX, and a big change from the way we did things in Swing, is that we do actually provide you with a set of chart controls. In Swing, you had like tables, you had trees and things like that, but there was no simple way to represent data graphically. There was no control, there was no component that you could actually use to represent data graphically. In JavaFX, if you want a pie chart, you don't have to write the graphics yourself. You can simply take the data that you've got, give it to a pie chart object, form a node, and have it displayed on the screen. So we'll talk about the basics of the charts in JavaFX. Then we'll talk about style sheets. Because JavaFX, again, big change between Swing and JavaFX, is that almost all of the nodes in JavaFX can be styled using CSS. So we'll talk through some of the details of how you use the style sheets, how you use the individual elements, and what kinds of things you can do with the charts that we've got. So there's a lot of flexibility in terms of how you can style things. Then we'll talk about the way that you can extend charts and actually take the base chart classes and add the functionality that you need, represent data in different ways, construct the graphical parts of the elements that you need, and do all of that kind of work. And then we're going to talk about one chart in particular. This is one of the charts that's supplied as part of the ensemble sample applications that we provide so that you can see how things work. And that's an interesting example of how you can extend the charts and add new kinds of information. So we'll talk through how that works and what's actually been done in terms of the way it works and also the styling that's been used. And then we'll just kind of wrap up at the end. So let's talk about the basics of charts in JavaFX. So here is a very simple example of a chart that has been created using the chart classes in JavaFX. It's just a line chart which represents 3 sets of data. Now, in terms of the major components that you've got there of the chart itself, there are 3 different things. So one is you've actually got the content that's being represented in terms of the lines that give you the data that's being presented. And then you've got a title, which obviously tells you what the chart is actually presenting to you. And then you've got a legend, which enables you, if you've got multiple sets of data, or even if you've only got one set of data, to be able to distinguish what the different lines on the graph mean. So you can see, okay, the blue line is portfolio 3, let's see, it's probably a bit difficult to tell between the yellow and the green line, but you can see it's portfolio 1 and portfolio 2. So we've got a way of informing the user of what the data represents. The nice thing about that is all these things are built into the chart nodes, so you don't have to add any of that extra graphics. You simply say, here's what I want to be the title, here's what I want to have as the labels for the legend, and it will do all of it for you. Another really nice thing about the JavaFX charts is that they have animation built in. And so if you do things like changing the data, or if you add data, or if you remove data, rather than it just jumping and suddenly you drop one piece of data out until the line changes position, there's an animation built in, so it will actually do a smooth transition and make it appear, that the line is moving gradually rather than jumping from one place to another. And that's a really nice thing, so that you can actually see a lot more sort of interesting visual effects. One thing about that is that when I first started looking at charts and I saw that we had animations built in, I thought, oh, that's good. So what I'd really like to do is change the way that it animates things. Now, unfortunately, you can't do that directly. So there's no property or way of accessing the animation that's used internally in the default charts. Now, I'll show you how you can apply animations yourself using your own charts, but in terms of using the standard charts that are available, you can't just dig in and say, okay, I want to change the animation. What you'd have to do is, if you wanted to do that, you'd have to subclass the chart, and then you'd have to fiddle around with it a bit. So it's not quite straightforward. It's not like a simple property that you can change. There are two types of charts in JavaFX. So there are two axes charts, which obviously this is an example of, where you have an X axis and a Y axis that represents two separate parts of the data. And then there's anything else. So we divide it into two groups, one which has two axes and one which doesn't have two axes. From the point of view of the API that you use, it's really sort of divided into three parts. And you can sort of think of this to some extent as sort of model view controller, but it's not quite. On the public side, you have the ability to skin the chart. So this is how we can describe the style sheet. We can describe the individual parts of that style sheet and let the system know how we want to style the various parts of the chart itself. Then you've got the control, which is really saying, okay, how do we want the data to be represented? What are we actually going to do with that data in terms of presenting it on the screen? And then we've got the behavior, which is what happens when you do present the information on the screen. So there's three different parts to that. Behavior obviously is sort of like the animation. So that's, like I say, the private part of the API where you can't directly change that. But the control and the skin is public, so you can change those to have different things happen. In terms of the actual API itself, if we look at the different charts that are available, everything comes from, I probably should have put node at the top, but so everything is a node because we need to put everything into our scene graph. But in terms of the charts itself, we have a superclass which is chart, which basically represents a visual representation of the data that we want to put on the screen. So that's our sort of most abstract concept in terms of a chart. Then we subclass that for the XY chart, which represents the chart with two axes. And then if we don't want a chart which has two axes, the only thing that we support at the moment as a standard chart is a pie chart. But if you want to create a different chart which doesn't require two axes, then you can simply subclass chart and produce your own version of that. From the XY chart point of view, we have a number of standard chart types that we can use in terms of displaying data. So there's an area chart where you're representing the data as being the area underneath the graph. You can do a bar chart, which is the classic bar chart with the different sizes of the bars to represent the data. Bubble chart, where you've actually got the information not just being the points on the graph, but also the size of the bubbles to represent a further piece of data in addition to the X and the Y axis. You've got the line chart, which is a simple set of points that are connected with lines, so you can see the trend in things. And then a scatter chart, which is really simply points that you're putting onto the graph to represent points of data. So that covers a very large range of most people's requirements. But as I say, if you want to do a different kind of chart where, again, if you're using an X and a Y axis and you want to do something different, then you can subclass the XY chart and you can have that use the functionality of a two-axis chart and the fact that you have an X-axis and a Y-axis, and then you can overlay the necessary functionality that you want on top of that. A little bit more detail about the XY chart. What that consists of is two sort of inner classes, one of which is data, and that represents the data that is going to be presented on the chart. So you're going to have information about the X and the Y values. And then there's also another value that you can have as part of your data, which is called extra value. So that is an object reference, so we can use that to represent another piece of data. Now, if you think about a bubble chart, you have the x and the y position of the bubble, but then you also have the radius of the bubble. So the radius would be your extra value there. So you can represent that third piece of data using the extra value. So it represents a data point that we want to plot on the graph, and then what we get is a node which we can access, and that will describe what the point that we're putting on the graph is actually going to look like. So again, if we want to do a bubble chart, we're going to use a circle with a radius which we represent by the extra value. We could also make that an ellipse. So if we wanted to have two different values to represent the x and the y radius of our bubble, we could do that as well. But we have a node which we can use, so we can completely change that depending on how we want to represent our data. So for a bubble chart, we can use a size of a circle. For a scatter chart, we can use different symbols to represent different pieces of data. For other charts that we're developing, we can use an arbitrary node for the data that we're actually presenting. Building on top of that, we then have the concept of another inner class, which is the idea of a series. And if you think about the first chart that I showed you the example of, where we had 3 lines representing 3 portfolios, each of those is a series. So it's essentially a set of data that we're graphing, and that is the data that is to be treated as a single set. So in the case of a line chart, that's the one that will be joined together with a line. And then if you want to represent multiple sets of data, you actually add multiple series of data to your chart. So it's fairly straightforward in terms of how you use that. And pretty logical, really. So let's talk about how we can use charts and style sheets in terms of actually changing the look and feel of the charts that we're using. So in terms of the charts that we present, all of the visual elements of that chart are represented by elements in the style sheet. And we have this thing called the Caspian style sheet, which is the sort of default style sheet that was created for JavaFX. And what that does is it sets all the standard values for things. And then if you want to change that, you can simply provide your own style sheet, and you can override various values of the elements within the style sheet, and then load that into your application so that when the application is presented, colors can change, the size of objects can change, all the different things that you can actually describe using the style sheet. In terms of the individual elements, there is the overall element, which is a chart, which clearly makes sense. Then you have a chart content, and that is a pane, not literally, in the sense that it's a pane that's displayed on the screen. And because you have a pane, obviously that is a node, so you can reference that, and you can reference all the qualities of a pane and subsequent a node being its superclass. So because it is a pane, it has all the same style elements as a pane does and a node does. In terms of the chart title, that is a label, so it has all of the style elements that a label has. So you can change the font, you can change the stroke width, you can change the color, just as you could any other label, but we reference it as the chart title specifically. Chart legend, because that's a little bit more complicated, you can see we've got the idea of 3 different labels. So the chart legend item is a label, and you can change the font and so on. And then the chart legend item symbol is a node. And in this case, what we've used is sort of 3 circles to represent the data. But if you wanted to do something more sophisticated, because it's a node, you can replace it with whatever you want. So in theory, you could use images, you could even use a video if you wanted to as your legend symbol, because it's just a node. So anything that you can put in a node, you can put in your legend. So just to show a couple of examples of how you can use that, like I say, you have the idea of it being a label, so you can change the font, you can change the size and so on. But you can also change things like the position. So here what I've done is I've set the FX title side to being bottom, and so rather than the title of the graph appearing at the top, which is the default position, it actually is presented at the bottom. And then similarly we can set the idea of the legend being visible, being true, That's actually default. So if you wanted to, you can turn that off if you don't want to have a legend for your graph. But also you can set the side where the legend is presented. So here, rather than having the legend at the bottom, I've said put the legend on the left of the graph. So you've got flexibility in how you can actually arrange the items as well as how you actually can present them. In terms of the XY chart, there's a number of other styling elements that you can use. These are all booleans, so you basically turn these things on or off. And in terms of like the first two, there's alternative column fill visible and alternative row fill visible. And what that does is it says that if you've got a number of rows or columns in your graph, if you set it to true, then it will use different colors for the alternate rows or columns to give a slightly different effect. So rather than having just a one color underneath the graph, it will actually alternate the colors of the different columns or the different rows in order to give an easier to view effect of where the changes in the rows and columns are. Similarly, you can say, okay, horizontal grid lines visible, vertical grid lines visible, and that allows you to turn off either or on either the vertical or the horizontal lines in the grid. So again, you could turn those lines off, and by using the alternate column or alternate row visible things, you can see where the changes between the columns or the rows are, but you don't have explicit lines in the graph itself. Similarly, you can set the horizontal 0 line, vertical 0 line to be visible or invisible, and that's the line that you'll see along the 0 axis, and you can actually set that so it's visible or not. Now, if you want to get a little bit more sophisticated, you can actually start fiddling with the axes themselves. And this was something which actually took me a while to figure out, because I was doing a simple application, and what I wanted to do is put a graph in my application, which is fine. Okay, that was easy. But the problem I had was that I wanted to use a black background. So I had a black background, and then I put my graph onto the black background, and straight away I couldn't see anything of the axes because all the axes are done in sort of dark grey, so it didn't really show up. And it did actually take me quite a long time to figure out how to change all the different elements of the axes so that I could make them visible on a black background. One of the things that it seems that I haven't found a way of doing it is you can't do this programmatically. So within your code, you can set certain style elements, but it seems that because these are nested style elements, I couldn't find a way at all of changing this programmatically. So if you want to do something like this, you do have to use a style sheet to actually change the way that the axes are presented on the graph. So what I've done here is I've said, okay, let's change the colors and also some of the sizes of the axes here. And what I've done, if you look at the x-axis, you've got the axis label itself. So if you want to change that label, again, because it's a label, you can change the font, you can change the size, stroke width, and so on. In the case of the axis, what that will do is it will affect the labels on the axis tick marks. So we're not talking about the label of the whole axis, it's the label of the tick mark. And here what I've done is I've said, okay, the axis we're looking at, change the tick mark label fill to be blue. Now, you have to change it to one color, so you're actually limited in terms of you can only change all of the labels. You can't change the X and the Y axis to be different colors. Similarly, in terms of the tick marks, so there's axis tick mark, which is the major tick mark, and so you can change the stroke color for that to be red. You can change the stroke width, so you can make it slightly wider if you want, so it's more obvious. Similarly, the axis minor tick mark is the little ones in between. Again, you've got the ability to make those visible or invisible, and so you can just say, okay, I want to set this to be green, and again, change the stroke width to be 3 points, and it makes it slightly wider. But this does allow you to have flexibility over how you change the way that the axes look. And like I say, if you're trying to put it on a darker background where the default colors won't show up, this is the way to do it in terms of changing that. JavaFX will not look at the color of the background and automatically go, ooh, you know, there's a dark background, let's use white rather than black as the default colors. Another thing that you can do is in terms of the ScatterChart symbols. So these are things that are used in for different series of data in a ScatterChart. So you'll have like a cross and a circle, a diamond, and so on, which are used to represent the different sets of data. Default ones, like I said, are specified in the Caspian style sheet, and then you can restyle them. And because there's the dash FX shape element of the style sheet, you can use that to define a scalable vector graphics path to say what particular shape you want to have displayed to you. So here what we can do is say chart symbol, we're going to set it to be bright blue, and then the shape that we're going to use, and we define a move to 0, 4, a line to 2, 4, line to 4, 8, line to 7, 0, line to 9, 0, line to 4, 11, and then that stop. So we'll see how that works in a moment, because what I'm going to do now is switch to a demo. Is that the big one? Yeah, that's a demo, yeah. Right. So, let me see, what shall I, where are we? Yeah, let me just run this one, just quickly. So this is just really showing the same chart that I showed you where you've got the, okay, beep. Actually, somebody did warn me about that because I didn't pray to the demo gods this morning, because I said, I'm not using any hardware today, so it's not going to be a problem. I'm going to find that the whole building will fall around me. Okay, so yeah, that's just showing you the same example that we showed before, and that is based on a style sheet. So, for example, if I go into in fact, this is the style sheet I've got here. So if I want to change some of that, I could change, let's change the tick mark and make it slightly narrower. And then build and run. So I'll just show that. Hopefully, yes. Yes, that makes it illegible. Okay. But you get the idea that we can change the color very easily by changing the style sheet. So that was just a simple one there. And then we'll also look at the idea of the scatter chart. And in fact, actually, let me stop that. Let's look at the other. So this is the CSS file. Let's see if I can remember how to do this. Should make it a bit bigger so you can see it. So setting the background color to red again, and then we've got the idea of specifying a scalable vector graphics path that we want to actually have displayed. And then what I'll do is, first of all, let me just quickly go in here. Yeah, so if I just comment out the loading of the style sheet first, so we see how it works. So we get yellow dots for the first one, then we get green squares for the next one, blue diamonds, blue crosses, blue triangles, red circles. Okay, so that's just the default styling for the individual elements that you get in a scatter chart. Now, if I apply the style sheet by uncommenting, and then just to remind you, this is default color 1 chart symbol, and I run that again. Let's just make sure I pick up the change, and then run. What we get now is we've still got the option 1, because remember, in computer science we count from 0 rather than from 1. And now if I add a new series, I get a red tick mark. So that's the restyled element in the style sheet. So I set the color to red, and then I drew the scalable vector graphics path was just drawing a tick mark. So it just shows you that we can change the symbol that we use for a particular option in a scatter chart just by changing the style sheet. And we'll go back to the PowerPoint. Hopefully that'll come back. Yes, good. Okay. Okay. So if we look at extending charts now, there we go, right. Right, so what I thought was, okay, let's look at some examples of how we can extend the existing charts. And rather than writing a whole new chart from scratch and creating a whole thing, what can we do with the existing charts and then extend them to give us different functionality? So I thought, okay, let's look at the idea of some simple drill down in a pie chart. What we want to do there is we want to say, okay, if you've got a pie chart that's being displayed on the screen, if a user clicks on one of the items in that, we want that to then drill down into a separate set of data and redraw the pie chart based on the data that is associated with that particular piece of the pie. So it's a drill down activity. Now, the thing about the pie chart is that in addition to it being a node, all of the slices of the pie are themselves nodes as well. So it's easy enough to say, okay, we can reference all of those nodes by doing slice a dot get node, and then what we can do is we can say, okay, add a mouse click listener to that, so when the user clicks on it, we want to actually do something to change something. And then in terms of that particular event handler, we're just going to do my pie chart drill down onto a different slice of data. And all that has to really do is just reload the data for the pie chart, and it will redraw itself. I'll show you an example of that actually running in a moment. We'll talk a little bit more about that when I show it to you in action. The other thing I thought of is, okay, let's have a pie chart where we can slide a piece of the pie out to highlight it. So if you're showing people data, you might want to actually slide a piece of pie out so you can talk about that particular information on its own. So the way I did that was, okay, so you're going to use an event handler, and what I had to do was to actually have a look at the code for pie chart in order to figure out how it worked. That was easy because it's open source. So if you go to OpenJFX, then you can actually download the source code for all the controls. So I could actually look at the source code for the pie chart and figure out what was actually happening underneath. And so you can get the region associated with the pie slice, and then you can use a deprecated method, a little bit cheeky, but you can use a deprecated method to get the arc node, because by default you get a node which represents the piece of the pie, but you don't get the arc node. So it's kind of a little bit fiddly in terms of the subclass. So you can get the arc node for that particular slice, and then that will give you the start angle where the slice starts, and also the length in terms of degrees that the slice is actually using. Then you can use the radius, combining with that information, you can say, okay, how far do I want to move it? And by knowing the angle, you can calculate which direction you want to move it into, which gives you a translation in the x and y coordinates using simple trigonometry to figure out where to move it to. And then by using a timeline, you can create an animation, you can slide the piece of pie out, and you can slide the piece of pie back in. So I'll show you a demonstration of that in a moment. The other thing is, because, like I say, all of the different elements of the pie chart are nodes themselves, you can register listeners on those, so it's really very easy to do whatever you really want to do. So you can do a click to indicate that you want to drill down, but you can just as easily add something like a mouse over event handler. So as you're moving the mouse around, you can highlight the particular element of the pie chart that you're moving the mouse over. You can do fade in, you can do fade out using timelines. Obviously, if you want to have keyboard events associated with a particular piece of the pie, that's a little bit harder because you've got to get focus, if you like, for that particular node. But in theory, I mean, if you want to do a little bit of conditional code, then you could certainly make that work reasonably easily. So let's have a quick look at a demo of this. Right, so just move that over a little bit. Right, so drill down pie chart. Yeah, let's try that one first. Right, so this is the idea of a drill down pie chart. So we've got a pie chart. Again, this is actually one of the ensemble demonstrations. So you can see the code for this in ensemble. And what we do is we've got the idea that as we move over the element, it highlights it by using a red border. That's actually a style sheet thing. So we're using a style sheet to indicate that the color of the edge to be highlighted is red. And then if I click on that, what that's going to do is reload the pie chart with a new set of data to indicate what we're drilling down onto. And we'll see that we get a nice animation as it does that. And that's the built-in animation. So that's the thing you can't change easily. You'd have to completely rework the pie chart. Unfortunately, there's no way of going straight back, so you have to run that again if you want to see it in action. But just do that one more time because it's rather nice. And then if we just click on that, we get a nice swirly animation where it uses timelines and reproduces the data. So that's quite a nice sort of simple, and like I say, it's a very simple thing because all you have to do is replace the set of data that the pie chart has with the new data of the drill down section, and all the animation is handled for you. So you literally just say set the data to this, and it happens automatically. So the movable pie chart, let me just open that up, piece of pie. Yeah, let's just have a quick look at this. So this was the piece of pie thing. So what I had to do was use this. Yeah, so this is where I got the actual selected piece. So as you can see, it's got a line through it because it's a deprecated method, which gives you the shape associated with the particular piece of the thing. So it is a touch fiddly because you have to cast that as an arc. So you strictly speaking, I should have an if statement before that to verify that it is an instance of arc before I do the cast, so I can avoid a cast exception. But because I know I'm working with a pie chart, I'm fairly safe that I can do that. And then you just calculate the angle of where you want to move it to, and then when you want to slide it, you work out the different distances, and you can set up the properties associated with your piece. So that's I use the center X and the center Y property because, of course, it's an arc. So you know that you always want to move it from the center. And so that just makes life easier because if you start using the X and the Y translation, because the top left-hand corner of each arc is not going to be in the center of the pie, it gets rather complicated. So by using the center of the arc, it makes it a lot easier in terms of actually doing the move. And then just do a timeline where you vary the X and the Y values over time, and you get the end result. So if I run that, what we'll see, hopefully, yeah, so same pie chart, same idea, we've still got the same style sheet, but this time if I click on one of the pie items, it just slides it out, and then I can slide it back in again. And so same thing if I want to do another one, it just slides in. It's just a nice little animation there. One thing I didn't do, I mean, it's a minor thing, but I probably should have done it to really sort of tidy it up, is I didn't move the label associated with the slice that I was moving out. So it probably would have been better to move the label at the same time. But that just would have been a few extra lines of code because you can easily reference the label from the pie itself. But it just gives you an idea of what you can do in terms of that. And then, again, just the simple example of the hover pie chart, which is similar to what we did before, but this time, rather than using CSS to indicate that we've got a red edge to it, what we're doing is we're using a timeline to fade in and fade out the different colors of that, so you highlight the particular one that you're using. So it's, again, fairly simple thing that you can do. Just show you the code for that quickly. Yeah, so that's the highlight code. So it's really just varying the opacity, again using a timeline. So you can change the opacity there, and then that's it. That's all you have to do, and then it just works. To there. Right. So let's talk a little bit about the idea of the candlestick chart. Once again, this is one of the charts that's available in the ensemble package, but I thought this is a good thing to look at because it's a nice example of how you can extend a chart, and it saved me having to think up a different way of representing data. So the idea behind this is that if you think about trading in shares, Trading in shares has a number of different pieces of information available about each particular part of the day or each day. So what you've got is you've got the open price, you've got the close price, you've got the high price during the day, you've got the low price during the day. And those could all be distinct pieces of data. So what we want to be able to do is to represent this data on the screen somehow. Now what you could do is you could use a bubble chart. So like I said, you could use the X and Y position. Actually, no, you couldn't even do it with that really very easily. But anyway, you need some way of representing it on the screen. So what we're going to do is use a XY chart, subclass it, and create our own way of representing the data. So what we have to do is obviously, in subclassing it, we've got to override the necessary methods that we need. So there's things like data item added, data item removed, data item changed, which need to cope with a new piece of data. Because we've now got 4 pieces of data for each element, we need to process those appropriately, because we're not dealing with just a single XY coordinate, we've got 4 pieces of data associated with it. We also, in those methods, this is where we can change the animation. So if we want animations to happen when, for example, we change the data, that's where we'll put a timeline to put in a new animation. So in the case of like the pie chart, if you really wanted to change the way it worked, what you could do is you could take the pie chart, you could use the code or understand from the code in OpenJFX what data item changed or data item added does, and then by overriding that particular method in your own implementation, you could put a different animation in. So there is a way of changing the animation, it's just a bit complicated. Then you've also got the idea of a series add, series removed, which is where you're adding a complete new set of data that needs to be represented on the screen. And then really the one that does most of the work is the idea of the layout plot children. And that's the thing where it actually does the drawing of the elements on the screen that represent the data. And so updates the nodes. And then you've also got the method which changes the axis, because if you start adding more data and it changes the range over which your data is valid, then you may need to redraw the axis. So if you've got an axis that goes from 0 to 100 and you add an element that's at like 150, what you need to do is rescale the axis so it then becomes 0 to 200. So that's a method that gets called in order to do that, and so you need to override that method in your implementation to make sure that it works in the right way for your particular data. So in terms of the point values, we remember we had the extra value as part of the XYChart data. So we had an X and a Y value, and then we had extra value. Extra value is an object reference. So it's easy enough to say, okay, well, it gives us an extra value, but we need 2 extra values. So all we do is encapsulate that in a class, and then we can provide a reference to an object of that type in our extra value. So it's easy enough. We could store 2, 3, however many pieces of data we want using that extra value reference. Then we create a separate class to use for the data value, like I say, attach that to the extra value, and that solves the problem for us. Now, in terms of this particular graph, we use style sheets quite extensively, and I will show you how extensively or what impact that style sheet has on what you actually see when I show you the demo in a little bit. So here what we're doing is we're setting a number of different things on our particular thing. So there's a number of these which are specific to our chart that we've created. So things like demo bar fill being red, that's not part of the standard XYChart style sheet. So we're adding some style sheet elements to our implementation of the graph. But then things like the background color, we're using some linear gradients to give us some nice pretty things that we can see. We've got different insets for the background, we've got some padding and so on, and then we've also got a drop shadow effect that we want to place on the actual candle within the candlestick graph. So if I show you the demo of this, right, so this is, let's see, let's close that. Right, so this is just the code for the candlestick graph. We're going to leave the style sheet in for now, and then I just show you that running. Run that one. And what we'll see is, right, so we see a nice, fairly complicated graph of data. So what we've got is, we've got the idea that's representing, the high point, the low point, the open and the close value of the different data. And then we've also got a line that connects the midpoints of those, so we can see the trend of the price over time and so on. And then we've also got the color associated with the different candles to represent two sets of data. So we can actually represent multiple sets of data if we want there, and so on. Or actually, no, I think no, it's not two sets of data. That's representing where we go up and where we go down. So green means we've gone up in price, red means we've gone down in price. So again, it's adding more complexity to the way that we've implemented it. So that's using the style sheet. So we get a nice, good-looking graph. Everything works very well. If we take the style sheet out by doing that, oop, that's not what I want to do, because that will not compile. Let's do that. Right. So I remove the style sheet and run this chart again. We see that it looks somewhat different. So that's what it is without the style sheet applied. And you can see how much impact having the style sheet applied to it actually makes. So it's the same concept. We've got the same lines in there, although the candle is the same width as the line. So we haven't changed anything there. We've got the same line connecting things. But it's not giving us anywhere near as much information as by using a style sheet. And it's not giving us anywhere near as useful a graph as if we actually have the style sheet implemented on top of that. So that's that. Good, okay. So, there we go. Just to kind of, no, didn't want to do that. Sorry. Right. So just to sort of wrap up then. JavaFX gives you a very powerful set of graphs or charts. So you've got all the standard types that you would expect, like line charts, bar charts, pie charts, and so on. So there's a lot of ways of expressing data graphically to your users. And by combining that with style sheets, you can really do a lot in terms of those standard charts. But the great thing is that even if you want to do something more complicated and you've got a different way that you want to represent the data, it's quite straightforward to actually subclass the necessary standard JavaFX classes and generate your own one where you can apply your own animations, you can apply style sheets as we saw with the candlestick graph and so on. You can do all sorts of interesting things, so you can have the idea of drill down, you can do 3D graphs if you want in terms of using, you could use a perspective transformation to give a 3D effect to it. With the work that's going on at the moment with the next version of JavaFX, so JavaFX 8, that will include more 3D concepts into it as proper 3D concepts. So it'd be really interesting to see what we can do with representing data in true 3D once we can start doing that in an easier way. So it makes charts a lot easier. I've only got one more slide. That's all I need to get through. Okay, so just places you can get more information. The Ensemble sample applications, as I say, it's got some very good examples of how to use the standard charts. The candlestick chart is included in that, so you can see how that works. There's a couple of very useful parts of the JavaFX tutorial, one of which is specifically to charts, and the other talks about style sheets in general and how they can be applied to not just charts but other things. And I've got to say I found that very useful. The JavaFX style sheet reference is invaluable if you're looking to use style sheets at any point, because it does list all the different elements that you can style and tells you, the inheritance between the different nodes and so on. And also fxexperience.com is a nice it's a kind of accumulation place where lots of blog entries get listed and useful information gets put up. So if you're interested in seeing what people are doing with this, then that's a great place to go as well. So I've got a bit of time left, so has anybody got any questions? Yeah.
How does the chart work in this situation where you have a very large amount of data? If you have a very large data set,
Well, I suppose it depends on what you're trying to do, because so if you've got a very large set of data, then the graphs will work with that, so that there's no issue over how much data you're trying to represent. Clearly, the more data you try and squeeze into a smaller screen. But some of the things that we also do is, so if you've got we can do lazy loading in some parts. So if there's things that are not being displayed on the screen at a particular given time, so if you're doing some scrolling across data, then we can do some lazy loading underneath to try and optimize the way things work on that. So we have tried to optimize for very large sets of data as far as possible, yes.
For the scatter plot, you showed an example of changing the symbol from one of the series. How
Yes.
do you do it from any series?
Okay, I will just quickly show you that. Yeah. So so this is default color 1 chart symbol. So what you could do is you could just have default color 2, default color 3, and so on, or default color 0. And then that would change the symbols for the different series. So by default, there are, I think, 8 different symbols that are defined. But using the style sheet, you could extend that if you really wanted to make multiple symbols and use that within your chart. So that's one way of doing it. Yeah.
That did not work past 8 series.
It doesn't work past 8 series.
Yeah.
No.
I
Well.
have a request on the Jira about that. Each cycle of that.
Yes. Okay. So, but what you could do is you could subclass and then extend it so that you could force it to use more than 8. It would be nice if by defining style sheets you could go beyond 8. Yeah. Yeah.
Do customization or like you want to change the scale XYChart.
Oh yes. Yeah, and yes, that's one question that does come up a lot is logarithmic scales. In 2.2 we do now support logarithmic scales, so there is a way of defining a logarithmic scale for a particular axis on a chart. But when you create the axis, you can define the scale that you use, and then you can also change that as the data set is changed. So if you add data, you can rescale the axis dynamically, but we do support logs as well, yeah. Yeah. Yeah, we don't support that. Not at the moment, no. Yeah.
I have several requests for announcements on the Jira about that. Sorry, but for scientific display, it misses a lot.
Right, yeah. I know they're always trying to do things like optimize performance on things like that. I don't honestly know what we've done. You know, John.
I had posted a message on the OTN forum about that. I had a video on YouTube with a performance issue.
Mm-hmm.
That was with 2.0 and 2.1, and when we switched to 2.2, suddenly it was very smooth and very fast.
Okay, so
maybe you need to try with the latest, right?
yeah. There you go. They're a clear, easy answer. Yeah.
One question. How is there any sample, or how would you suggest to go if you want to have a zoom inside the XYChart? Not to zoom, is it?
Well, the way you could implement that is because the chart is a node, you can simply pick up mouse events. So you could actually pick up the mouse wheel events, for example, and then all you need to do is use an event handler, and then you scale the chart. Yeah. So you could do that. That would not be too difficult to do it.
So on the logarithmic axes, are you stuck with just plain and logarithmic, or you can provide your own adding function?
I will say that I do not know. I was talking to one of the engineers just the other day, and he was saying, "Oh yeah, do tell them about logarithmic scales." I've told you about logarithmic scales. Unfortunately, I don't know quite how they've implemented it. I haven't experimented with that in terms of how it actually works, so I can't give you an answer for that directly.
Do you ever
I know that's something we are working on, is how to do that. At the moment, you're going to...
You don't need to take a snapshot. In 2.2, take a snapshot of the chart, format it to the current data, and use editable.
Thank you.
Did you try and configure this to the web as an applet? What was the performance?
I've not tried deploying it as an applet. I mean, because it's just running as Java, I wouldn't expect the performance to be lower than if you're using it as a straightforward application, because the rendering is going to be the same, whether it's going from a web browser or whether it's going from a native, well, not a native app, but a standard application. So I wouldn't expect to see any significant difference in performance.
Do you have any support for tree maps?
Tree maps. Not at the moment, as far as I know. No, I'm not. Well, I mean, you can design your own based on what we've got here. But I mean, we have trees, but not. I don't know about tree maps. Yeah. Okay. Well, thank you very much. Oh, one more question.
It's like a common thing you want to do, like your legend had represented 3 lines, is to click those on and off and have those lines disappear from clutter. Is that something you're working on, or you try to standardize it, or I mean, extend it to that?
Well, you could. I think you can do that, because I'm trying to think. You should be able to get access to the legend, in which case you can get access to the node within that, which represents the. You probably have to look at the code for one of the charts to find out how it does it. But I'm pretty sure that you could reference the node, which is representing that particular in the legend, which represents that set of data. If you get access to that node, you could simply put an event handler on that for a mouse click, and then use that to turn on or off the data in the graph. So you could do that without too much work. I haven't tried it, but I don't think it would be too hard to do that. Nope.
Talking about exhaustive charts, what would you recommend if I want to draw some custom graphics about this chart? For example, if I want to draw a line from one candle to another candle, how can I do it?
Well, because the candlestick, if you look at the candlestick chart, because that implements an XY chart completely, you're overriding the draw method. I can't remember the one which actually redraws the plot of the things. So if you wanted to join data, then it's very easy, because within that method, all you need to do is figure out which points you want to join up, and then you just draw a line between them. So it would be just part of your plot. So you're free to do whatever you want within the plot. Do you see what I mean? Yeah.
There are methods in the axis class that allow you to translate your numbers into screen coordinates. So there you can find where your dots are on the line.
Okay, well, thank you very much.